Hi, my name is James. I'm in my late 30s. I'm from Chicagoland area, Illinois, Midwest out here. This is going to be my week 1 assignment to the Introduction to Audio Production course. I'm going to be going over the connections overview and the digital audio workstation. Both video lectures seem to go hand in hand, so figured I could squeeze a little bit of information on both of them. All right, let's dive right in. Signal flow from our sound source. Sound source, be it, let's say vocals, acoustic guitar, or what have you. Well, we already know that from our sound source, sound pressure variations in the air are then picked up by an input transducer, which we commonly call a microphone. A dynamic microphone, condenser microphone. It's really your choice depending on your application and what your needs for your specific project is. Right now, I'm using a large diaphragm condenser. You know, we've talked about polar patterns, frequency response. Like I said, it really depends on what your project is and what your ear wants to hear for what mic you're using. You know, all situations may vary. From the input transducer, these sound pressure variations in the air are then converted to voltage variations. They're picked up as, not even converted, they're just picked up as voltage variations, kind of like electrical pulses, as a low-level audio signal. This is usually via an XLR balanced cable from your microphone. Then the signal flow travels to your audio interface, or a standalone mic preamp first, whatever your setup may be. But usually most of these audio interfaces these days have a built-in preamp section. In the preamp section, here you can apply or set any gain staging or trim or clip controls to avoid any distortion or pops. To really find that sweet spot, you know. So at this time, it would be best to amplify or attenuate properly to get that clean, precise sound. Now, the audio signal is traveling at line level to the analog digital converter inside of your audio interface. At this point, the line level audio is then converted to a digital language that your computer can understand. This is called binary info. It's a series of ones and zeros. It's a complex computer code containing our audio from raw source to this binary information. This information is then sent via USB or FireWire to our computer or digital audio workstation. Some people refer to the computer and the software, the digital audio workstation, but I like to include the audio interface also. It's kind of like the computer being the brain, the software being the blood, and the interface being the bone. Let's continue. I would like to add that the software inside your DAW, digital audio workstation, many different types, brands, you know, these interfaces all are fairly similar though. Just to give you an overview, it's probably one of the most powerful pieces of your digital audio workstation. At this point is where you can adjust things, trim your clips, you know, edit them, set pans, you know, send it to your final mix and mastering process and whatnot, but I'm not going to get too much into that. I'm sure we'll discuss this in later weeks. Anyhow, continuing on with our signal flow, now that we have our finalized piece of audio, or for that matter, real-time monitoring come into play here also. So, now everything is moving in reverse, because that signal flow now travels back out via the same FireWire or USB cable, again as binary information, the ones and zeros that I talked about earlier, to the audio interface, now to the digital to analog converter. As a line level audio signal, this is usually done via a TS, TRS, or an XLR balanced cable to your amplifier or monitors, or maybe headphones, as a high level audio signal to the said output transducers, or speakers, as sound pressure variations in the air that we perceive as loudness.